In 1938, fishermen off the coast of South Africa pulled up something impossible, a fish that science declared extinct for 66 million years. The coelacanth, a living fossil that shouldn't exist but did. In 1902, European scientists dismissed reports of a strange horse-like creature in the Congo as native superstition. Then they found one. The okapi, a real animal hiding in plain sight, the giant squid, the mountain gorilla, the Komodo dragon, all once considered myths, legends, or misidentifications, all now confirmed, cataloged, and studied. So when someone claims to have seen Bigfoot or photographed something strange in a remote lake or found tracks that don't match any known animal, the question isn't as simple as real or fake. The question is, how do we know the difference between undiscovered and imaginary? Before we dive deep into this question, if you're the kind of person who thinks mystery deserves more than easy answers, who values curiosity over certainty, hit that like button and subscribe, because this isn't going to be another list of cryptids. This is about why cryptozoology exists at all, what it reveals about human nature, and why the line between science and folklore is more complicated than you think. Let's start with a question most cryptid videos never ask. What exactly is cryptozoology, and why does it occupy this strange space between science and storytelling? The term cryptozoology was coined in the 1950s by Belgian-French zoologist Bernard Heuvelmans. It comes from the Greek, cryptos meaning hidden, zoon meaning animal, and logos meaning study. Literally the study of hidden animals. Heuvelmans wasn't interested in proving monsters existed. He was interested in the gap between folklore and formal scientific discovery. He asked how many animals that local peoples know about haven't yet been cataloged by Western science. How many species exist in the margins, in remote regions, waiting to be properly documented? This is a legitimate question. Western scientific taxonomy has existed for only about 250 years. Indigenous peoples have lived in their environments for thousands. There's bound to be knowledge that hasn't been transferred from traditional understanding to scientific classification. But cryptozoology occupies an uncomfortable position. It's not quite zoology because it deals with unproven claims. It's not quite folklore because it attempts to apply scientific methodology. It exists in the gap, investigating reports of animals that might exist based on eyewitness accounts, physical traces, and cultural traditions, but which haven't been confirmed through the rigorous standards science requires. Mainstream science doesn't recognize cryptozoology as a legitimate field. There are no university cryptozoology departments, no peer-reviewed cryptozoology journals in the traditional sense, no cryptozoology degree programs. And this creates a feedback loop. Because it's not academically legitimate, serious scientists avoid it, which means it attracts more amateur investigators, which further damages its scientific credibility. Yet the work itself, investigating claims, analyzing evidence, attempting to identify unknown animals, isn't inherently unscientific. The methodology can be sound. The problem is that the subject matter rarely cooperates. So cryptozoology exists because of a genuine phenomenon. The gap between what local knowledge claims exists and what science has confirmed exists. The question is whether that gap contains undiscovered animals or just misidentifications, hoaxes, and folklore given physical form by expectation and perception. Before we ask whether cryptids are real, we need to understand why humans are so primed to believe in them. And the answer lies in how our brains process incomplete information. Human brains are pattern recognition machines. We evolved to identify threats quickly, often from partial information. A rustle in the grass might be wind, or it might be a predator. Our ancestors who assumed predator and ran away survived more often than those who waited for confirmation. This creates a cognitive bias towards seeing meaningful patterns even in random data. We see faces in clouds. We hear voices in white noise. We construct narratives from coincidence. And crucially, we remember the hits and forget the misses. Geography plays a role too. Cryptid sightings cluster in specific types of locations, remote wilderness areas with low population density, regions with limited scientific documentation, places where nature still feels larger than human presence. Throughout history, the edges of known geography have been populated with mysterious creatures. Medieval maps marked unexplored regions with dragons and sea monsters. Not because dragons existed there, but because unknown spaces need to be filled, if not with knowledge, then with imagination. Folklore serves important cultural functions. Monster stories mark boundaries. Don't go into the deep forest. Don't swim in that lake. Don't wander far from camp. The monster becomes a personification of legitimate danger. Whether the monster itself exists matters less than the function it serves, keeping people safe from real hazards like getting lost, drowning, or encountering actual dangerous animals. Fear is also a powerful memory enhancer. An ambiguous encounter in the woods, a strange sound, an unclear shape, a moment of genuine terror gets encoded in memory with heightened emotion. Over time, as the story is retold, ambiguity resolves into certainty. The unclear shape becomes a distinct creature. The possible becomes probable, then definite. And there's social reinforcement. In communities where cryptid belief is common, reporting a sighting gains you attention, validates your experience, and connects you to a tradition. Skepticism might isolate you. Belief integrates you. Perhaps most importantly, there's a hunger for mystery in an increasingly explained world. Every square foot of land has been satellite mapped. Wildlife is tracked, tagged, and monitored. The unknown shrinks daily. Cryptids represent resistance to that complete rationalization of nature, a hope that some things remain undiscovered, that the world still holds secrets. None of this proves cryptids don't exist, but it does explain why belief in them would persist even if they didn't. The question then becomes, can we separate the psychology of belief from the possibility of actual undiscovered animals? The giant squid was a sailor's tale for centuries. Stories of massive tentacled beasts attacking ships, pulling men into the depths. Scientists dismiss these as exaggerations, misidentifications of known squid species, or pure fiction. Then in 2004, Japanese researchers captured the first photographs of a living giant squid in its natural habitat. The creature was real. Sailors hadn't been lying. They'd been encountering an animal that science simply hadn't confirmed yet. The okapi was known to the Mbuti people of the Congo for generations. When European explorers heard descriptions, a horse-like animal with zebra stripes, they assumed it was a myth or a confused description of a known animal. In 1901, Sir Harry Johnston obtained an occupies skin and skull. By 1902, the species was scientifically described. The African unicorn was real all along. Indigenous knowledge had been accurate. Western science had just been slow to listen. Mountain gorillas weren't scientifically described until 1902, despite local accounts of their existence for centuries. The Coelacanth, believed extinct for 66 million years, was found alive in 1938. The Komodo dragon, the world's largest lizard, wasn't known to Western science until 1910, despite being well known to Indonesian islanders. And discoveries continue. New species are identified every year, thousands of them. Most are small, insects, fish, microorganisms. But occasionally something larger surprises us. New primate species, new large mammals. In 1992, the Saiola, a large forest-dwelling bovine, was discovered in Vietnam, a creature the size of a deer that science had completely missed. There's a pattern to these discoveries. They happen in remote locations with difficult terrain, low human population density, and limited scientific access. They're often animals that local populations already knew about, and they're usually discovered when scientific resources are finally directed to systematic surveys of these regions. So what does this teach us? That absence of evidence isn't always evidence of absence. That traditional knowledge often contains accurate information, that scientific taxonomy is incomplete and probably always will be, and that dismissing all cryptid claims as impossible would be historically inconsistent with how species discovery actually works. But there's a crucial difference between these confirmed discoveries and most cryptid claims. These animals were found in genuinely remote, undersurveyed regions. They were biological possibilities, animals that fit into known ecological niches, with plausible food sources and habitats. And once serious scientific attention was directed to finding them, they were found relatively quickly. Which brings us to the uncomfortable question: if some cryptids turned out to be real, Why do most remain unproven despite decades or centuries of searching? For a species to persist across generations, you don't need one individual, you need a breeding population, typically dozens to hundreds of individuals to maintain genetic diversity and avoid inbreeding collapse. Take Bigfoot as an example. The Pacific Northwest, where most sightings occur, is not uninhabited wilderness. It's crisscrossed with logging roads, hiking trails, campgrounds, and towns. Millions of people visit these forests annually. Camera traps monitor wildlife throughout these regions. Hunters spend thousands of hours in the woods. Yet in all this time, with all this human presence, with all these cameras, we have no clear photographs, no bodies, no bones, no definitive physical evidence. For a breeding population of large primates to exist in these forests without leaving confirmed evidence stretches biological plausibility. Large animals require substantial food. A creature the size of Bigfoot would need thousands of calories daily. That means a breeding population would need a prey base capable of sustaining dozens of large omnivores or carnivores. This would have measurable impacts on local ecosystems, impacts we should be able to detect even if we never saw the creatures themselves. And now we have environmental DNA analysis. Every animal sheds genetic material, skin cells, hair, waste. eDNA surveys can detect species present in tiny numbers. Multiple eDNA surveys of regions with frequent Bigfoot sightings have found no unknown primate DNA. Loch Ness has been surveyed more thoroughly than almost any body of water on Earth. Sonar sweeps, underwater cameras, eDNA analysis all found no large unknown animals. The Loch simply cannot support a breeding population of large creatures. The food chain isn't sufficient. Then there's the hoax problem. Many famous pieces of cryptid evidence have been definitively proven fake. The Patterson-Gimlin Bigfoot film has been claimed as a hoax by multiple people involved. The surgeon's photograph of Nessie was confessed as a toy submarine. When the most famous evidence is demonstrably false, it casts doubt on everything else. Misidentification explains a significant portion of sightings. Bears standing on hind legs account for many Bigfoot reports. Logs, waves, and waterfowl explain most lake monster sightings. Known animals seen in unusual conditions or from unusual angles become unknown creatures. And there's a statistical issue. If these creatures existed in the numbers and locations claimed, we should have far more evidence than we do. Not just eyewitness reports, but roadkill, bones, clear photographs, DNA evidence, ecological impacts. The absence of this evidence, especially in the modern era of ubiquitous cameras and scientific monitoring, is telling. The genuinely remote regions where unknown large animals might still exist, deep ocean trenches, unexplored cave systems, densest tropical rainforests, are not where most cryptid sightings occur. Bigfoot is reported in recreational forests. Nessie is in a lake that's been studied for decades. These aren't unknown wildernesses. They're well-traveled, well-documented areas. This doesn't make every sighting a lie. People genuinely see things they can't explain. But it does suggest that most of what people are seeing isn't unknown animals. It's misidentified known animals, hoaxes, or perception errors. So why don't scientists take cryptozoology more seriously? The answer lies in how science actually works. Science operates on a principle. Extraordinary claims require extraordinary evidence. This isn't about being closed-minded. It's about resource allocation and evidentiary standards. To confirm a new species requires physical specimens, DNA evidence, photographs clear enough for identification, or multiple independent confirmations. Blurry photographs don't meet this standard. Eyewitness testimony, while valuable for generating hypotheses, doesn't meet this standard. Even footprints don't meet this standard. They can be faked, misinterpreted, or created by known animals under unusual conditions. Compare cryptid evidence to how new species are actually confirmed. When the Sala was discovered, researchers obtained specimens, DNA samples, and clear photographs within months of the first scientific expedition. When new species are found, they're found definitively, not through decades of ambiguous sightings, but through systematic scientific investigation that produces conclusive evidence. Scientists face a genuine dilemma. Investigating cryptid claims could potentially lead to legitimate discoveries, as history has shown. but it also risks wasting limited research funding, time, and professional reputation on wild goose chases. Most choose to focus on research with higher probability of productive results. And there's a spectrum here. Some cryptid claims are more plausible than others. An unknown large fish species in the deep ocean? Biologically plausible. We're still discovering deep sea species regularly. A population of prehistoric reptiles in a well-studied lake? Biologically implausible for multiple converging reasons. This doesn't mean everyone reporting cryptid sightings is lying or foolish. Most are sincere. They saw something they couldn't identify, and in the absence of a clear explanation, they reach for the one their culture provides. This is human nature, not stupidity. The uncomfortable middle ground is this: science should remain open to possibility while maintaining rigorous standards of evidence. Cryptozoology should be willing to accept that most claims will have mundane explanations while continuing to investigate the genuinely mysterious. Both sides need each other. Skepticism without curiosity becomes dogma, but curiosity without skepticism becomes credulity. To understand why cryptozoology persists despite lack of evidence, we need to follow the money. Television discovered that cryptid content is profitable. Shows like Finding Bigfoot ran for 9 seasons. 100 episodes of searching without ever finding Bigfoot. The business model wasn't about discovery, it was about the search itself. Each episode could tease new evidence, new sightings, new hope, without ever having to deliver a definitive conclusion. And that's intentional. A cryptid proven real is a story that ends. A cryptid proven fake is a story that ends. But a cryptid that remains tantalizingly just beyond proof? That's a story that can continue indefinitely, generating content, revenue, and audience engagement for years. Tourism built around cryptids generates significant local revenue. The Loch Ness monster is worth millions to the Scottish economy. Pacific Northwest towns embrace Bigfoot as a mascot. Mothman transformed Point Pleasant, West Virginia, into a tourist destination. Social media has amplified this dynamic. Cryptid content performs well algorithmically. It's engaging, shareable, and generates strong reactions from both believers and skeptics. This creates financial incentive for content creators to produce cryptid material regardless of evidentiary quality. This ecosystem also incentivizes hoaxes. A convincing fake Bigfoot video can generate millions of views, media attention, and potentially significant income. Even when hoaxes are exposed, the original viral spread often far exceeds the debunking coverage. The line between legitimate investigation and entertainment has blurred. Some cryptozoologists are serious researchers applying scientific methodology. Others are entertainers using the veneer of investigation to create compelling content. And audiences often can't distinguish between them. What we've created is a perpetual mystery machine, a cultural and economic system that benefits from mystery never being resolved. True believers keep hoping for discovery. Skeptics keep debunking. Media keeps profiting from the conflict. And the cryptids themselves remain conveniently just beyond definitive proof. So what's the future of cryptozoology in an age of increasingly sophisticated detection technology? Environmental DNA analysis is revolutionizing species detection. A single water sample can reveal every vertebrate species that's been in that body of water recently. Soil samples can detect terrestrial animals. This technology makes it increasingly difficult for large unknown animals to remain hidden in accessible areas. Camera-trap networks combined with AI image recognition can monitor vast wilderness areas continuously, automatically identifying and cataloging every animal that passes. Some networks now cover hundreds of square miles, creating constant surveillance of regions where cryptids are allegedly common. Satellite imagery, thermal detection from aircraft, acoustic monitoring. The tools available for species detection have advanced dramatically. These technologies have discovered new species, tracked endangered animals, and mapped wildlife distributions. Yet they consistently fail to detect the cryptids allegedly inhabiting these same areas. But there are genuine frontiers remaining. Deep ocean trenches are still largely unexplored. Vast cave systems exist worldwide with ecosystems we've barely studied. The densest rainforest canopies likely contain species we haven't documented. And we continue to find new species in these environments. Strange deep-sea fish, bizarre cave-adapted creatures, canopy-dwelling species unknown to science. So cryptozoology, properly understood as the search for undocumented species in underexplored ecosystems, has legitimate work to do. The key distinction is between accessible wilderness where cryptids are commonly reported and genuinely remote environments where new species are actually discovered. Bigfoot isn't reported from the Amazon basin's unexplored interior. He's reported from Pacific Northwest forests accessible by car. Nessie isn't in the Mariana Trench. She's in a lake that's been surveyed extensively. The future of cryptozoology might be letting go of the famous cryptids that keep the field in pseudoscientific territory, and instead focusing resources on genuinely underexplored ecosystems using rigorous scientific methodology. Stop searching for Bigfoot in well-traveled forests and start systematically surveying rainforest canopies. Stop looking for lake monsters in recreational lakes and start investigating deep ocean ecosystems. The question is whether cryptozoology wants to be entertainment or science. Entertainment can continue the eternal search for famous cryptids. Science requires accepting when evidence suggests an animal doesn't exist and redirecting effort toward more promising frontiers. So we arrive at the real question, the one that cryptozoology is actually about. What do we lose when mystery dies? For most of human history, the world was full of genuine unknowns. Regions no human had visited, creatures no one had cataloged, phenomena no one could explain. Mystery wasn't a choice, it was reality. We've systematically eliminated that mystery. We've mapped every continent, charted every ocean, cataloged millions of species, explained natural phenomena through science. We've traded mystery for knowledge, and overwhelmingly, that's been positive. Knowledge saves lives, cures diseases, helps us understand our place in nature. But there's a psychological cost. When everything is known, cataloged, and explained, the world feels smaller, more controlled, more mundane. The sense that nature holds secrets, that discovery remains possible, that humanity hasn't figured everything out, that sense fades. Cryptids, in this context, become symbols. They represent the hope that some things remain unknown, that nature hasn't been completely rationalized, that wonder is still possible. Whether Bigfoot exists matters less than what Bigfoot represents. The last wild places, the limits of human knowledge, the possibility that we've missed something. And here's the uncomfortable tension. We want mystery, but we also want truth. We want the world to be more magical than it appears, but we also don't want to be fooled. We want undiscovered species to exist, but we want evidence before we believe. If tomorrow Bigfoot were definitively proven not to exist, if technology advanced to the point where we could say with absolute certainty that no such creature inhabits North American forests, what would we lose? Not a real animal, because it never existed, but perhaps something else. The hope that large, mysterious creatures could still hide in our own backyards, that the world retains surprises. Is that hope valuable even if it's false? Or is truth always more important than comforting mystery? Do we need cryptids, not because they exist, but because we need to believe something could exist beyond what we've discovered? Perhaps the real tragedy isn't that cryptids don't exist. It's that we need cryptids at all, because the actual mysteries of nature, how consciousness emerges, how life began, the vast scales of deep time and cosmic space, these are profound, awe-inspiring, and real. But they don't come with fur and footprints. They don't leave blurry photographs. So ask yourself, do you want Bigfoot to be real because you want the world to be more mysterious? Or because the mysteries the world actually contains aren't enough? Because the forests are still mysterious. The oceans are still full of unknowns. Nature is still fundamentally strange and wonderful. We just have to be willing to see the mystery that actually exists instead of the mystery we wish existed. Cryptozoology, at its best, is about that search. At its worst, it's about avoiding the uncomfortable reality that we live in a comprehensible world. And sometimes that comprehension reveals that the monsters were never there. Thanks for joining this exploration of cryptozoology, not as a catalog of monsters, but as a window into how we balance hope and evidence, mystery and knowledge. Here's a question for you. If you could choose between living in a world where Bigfoot definitely exists, but we'll never prove it, or a world where we prove definitively that Bigfoot doesn't exist, which would you choose? And what does your answer reveal about what you value, comforting mystery or uncomfortable truth? Share your thoughts honestly in the comments. If you're interested in content that explores not just what might be true, but why we want it to be true, content that respects both your curiosity and your intelligence, consider subscribing and turning on notifications. We bring this same thoughtful approach to every mystery, myth, and unexplained phenomenon we examine. And if you want to continue exploring the line between science and speculation, check out our videos on ancient alien theories, the Bermuda Triangle, or the Loch Ness Monster. Each examines not just the claims, but the human psychology behind them. Until next time, stay curious, demand evidence, but never lose the capacity for wonder. Because the real world, properly understood, is strange enough.